Hi everybody, welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host. It is the 4th of February 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, that's right. There's a lot going on in the universe, of course, and while we're talking about the universe, that's why we're here, just before Hallie gets here, we're going to be talking about the heaviest black holes in the universe. What's up with those things? Apparently there's a bit of a situation where some of them can merge together, and that causes galaxies. You know, there's a black hole in the center of most galaxies, and when those things merge, there's a lot of observable science going on there. So we're going to talk a little bit about that, and also there's new tech on the moon for the first time. You know, IM-1 landed on the moon, and it did land on its side, but they're actually using this remarkable lander straight away. It's successful, it's working, and that's all that matters. And the new tech that is on the moon is the first tech there in 50 years. Fantastic stuff. And you remember OSIRIS-REx. Now, latest from OSIRIS-REx is that it's done something pretty remarkable that's beyond its design. And this is something that we keep hearing in space annals, is that our probes and ships that we keep sending out there, like I remember Voyager was only meant to last about 4 years, and it's still going all of these years later, and this is just a common theme throughout our probe builds. And well, we've got another one. We'll talk about that as well. That's OSIRIS-REx. I love that name. And of course, later on we'll do a bit of a Rosetta roundup. Rosetta was one of my favourites. Of course, I keep bringing up my favourites because they're fun to talk about. This is the one that landed, the first ever landing on a comet. And what a great little piece of history that was. So we'll have a look at that. And meanwhile, here's Hallie.
Hey, you started without me.
Sorry, Hallie, I was just making up for lost time.
How can you do that? Time is intangible.
Well, only a couple of weeks ago you said I was late, and even then only by a few nanoseconds.
But reading the intro without me is just cheeky.
Oh, well, Hallie, the truth is I went to the cinema this afternoon, and I'm just running late here in the studio, so I'm just trying to catch up.
I knew it was something like that. I hope it was worth it.
Oh, I saw the new Dune Part 2. Totally magnificent, of course.
Oh, yeah, the spice must flow. The sleeper must awaken.
Speaking of which, let's do the first story, Hallie, all about super heavy black holes. You start.
Okies, hit it. The merging of two supermassive black holes is a phenomenon that has long been predicted, though never directly observed. One theory put forth by astronomers is that these systems are so massive that they deplete their host galaxy of the stellar material needed to drive their merger. Using archival data from the Gemini North Telescope, a team of astronomers have found a binary black hole that provides strong evidence supporting this idea.
The team estimates that the binary's mass to be a whopping 28 billion times that of the Sun, qualifying the pair as the heaviest black hole binary ever measured. Not only does the measurement give valuable context to the formation of the binary system and to the history of the host galaxy, but it supports the long-standing theory that the mass of a supermassive black hole binary plays a key role in stalling supermassive black hole mergers.
Using archival data from the Gemini North Telescope, a team of astronomers have measured the heaviest pair of supermassive black holes ever found. The merging of two supermassive black holes is a phenomenon that has long been predicted, though never observed. This massive pair gives clues as to why such an event seems so unlikely in the universe.
Nearly every massive galaxy hosts a supermassive black hole at its centre. When two galaxies merge, their black holes can form a binary pair, meaning they are in a bound orbit with one another. It's hypothesized that these binaries are fated to eventually merge, but this has never been observed. The question of whether such an event is possible has been a topic of discussion amongst astronomers for decades. In a recently published paper, the Astrophysical Journal, a team of astronomers presented new insight into this question.
The team used data from the Gemini North Telescope in Hawaii, one half of the International Gemini Observatory operated by NSF's NOIR lab, which is funded by the U.S. National Science Foundation. To analyze a supermassive black hole binary located within the elliptical galaxy B20402 plus 379. This is the only supermassive black hole binary ever resolved in enough detail to see both objects separately, and it holds the record for having the smallest separation ever directly measured, a mere 24 light-years.
While this close separation foretells a powerful merger, further study revealed that the pair has been stalled at this distance for over 3 billion years, begging the question, what's the holdup? To better understand the dynamics of this system and its halted merger, the team looked to the archival data from Gemini North's multi-object spectrograph, GMOS, which allowed them to determine the speed of the stars within the vicinity of the black holes, allowing them to map the stars' increasing velocities, and from that they were able to infer the total mass of the black holes residing there.
Whether the pair will overcome their stagnation and eventually merge on timescales of millions of years, or continue in orbital limbo forever, is yet to be determined. If they do merge, the resulting gravitational waves would be 100 million times more powerful than those produced by stellar mass black hole mergers.
It's entirely possible the pair could conquer that final distance via another galaxy merger, which would inject the system with additional material, or potentially a third black hole, to slow the pair's orbit enough to merge. However, given B20402 plus 379 status as a fossil cluster, another galactic merger is unlikely. Hey, this one's all yours, Hallie.
Thanks, Steve. I've got some very short takes for us.
Okay, let's hear them.
For the first time in more than 50 years, new NASA science instruments and technology demonstrations have been operated on the Moon. A suite of 6 science instruments and tech demos was delivered to the South Pole region of the Moon on February 22 by Intuitive Machines' Odysseus lander. The mission, known as IM-1, was the first successful delivery for the agency's Commercial Lunar Payload Services, or CLPS initiative, and Artemis campaign. Preliminary telemetry indicates that NASA's OSIRIS-APEX spacecraft, formerly known as OSIRIS-RX, recently completed an operation that brought it 25 million miles closer to the Sun than it was designed to function. Preliminary telemetry indicates that NASA's OSIRIS-APEX spacecraft successfully completed a 2-month operation that brought it 25 million miles closer to the Sun than it was designed to function. The OSIRIS-APEX spacecraft, formerly known as OSIRIS-RX, repositioned one of its 2 solar arrays to shade critical components from the Sun's heat during its January 2 close pass, or perihelion. When it returned to a thermally safe distance of about 60 million miles from the Sun in early February, OSIRIS-APEX rotated its array back into place to help generate power. The limited telemetry available suggests that OSIRIS-APEX performed as predicted during the perihelion. It will take a few months for the mission team to conduct a full assessment of the spacecraft's performance, during which it flew to roughly half the distance between Earth and the Sun. The close pass of the Sun, or perihelion, was the first of 7 the spacecraft will make on its journey to study asteroid Apophis, which is expected to have a rare close encounter with Earth in April 2029. And now something just to rattle all the flat earthers out there.
Oh, this'll be good.
A free app, called Galactic Compass, has been developed by Matthew Webb, was released on the Apple App Store on February 15. It's designed to always point users in the direction of the galactic center, no matter Earth's position in the cosmos. Webb's inspiration for the app stems from years of teaching himself to always know where to look for the galactic center, which shifts as we move through space. He wrote about the reasoning behind Galactic Compass recently on his website, which also announced the app's release. I would end up pointing through the pavement or down a street and thinking, that's where it is, Webb said in the post. Eventually then I had this picture of myself, and the Earth, and the solar system, and the center of the galaxy which had initially been whirling round me, and now it had flipped, I was turning around it. It was wildly situating. So if you ever get lost in space, Steve, you can finally get your bearings.
Good to know, Hallie, but that's not something I'll ever have to worry about.
Not with your groundhog ways. I wouldn't think so either.
Any more today, Hallie?
That's it from me. You should do the newsletter plug now.
That is a great idea, and you can get your hands on the Astronomy Daily newsletter each day in your email by visiting these places. Bitesz.com, that's bitesz.com, and spacenuts.io, and dropping your email address in the slot provided. Then you'll be up to date with all the news about space, space science, and astronomy from all around the galactic neighbourhood. And while you're there, check out the back editions of Astronomy Daily and Space Nuts, featuring Andrew Dunkley and astronomer-at-large Professor Fred Watson of the Australia Observatory. We can also be found at the Space Nuts podcast group on Facebook, and look for us on Spotify. And do like my friends do and listen to us in the car. Great idea. Astronomy Daily with Steve and Hallie. Space, space science, and astronomy. Thanks for staying with us. It's Astronomy Daily on the 4th of February 2024 already. Boy, this year is just flying by. But anyway, if you're a regular listener to this program, you'll know that I am a huge fan of asteroids and comets. I don't know why. I just think they're intriguing and wonderful and strange, and I just love it when we interact with them. I think it was a wonderful joke when they fired a bullet into the asteroid, and I really did feel like the dinosaurs were avenged in that moment. Wonderful. So yeah, I found a little story about Rosetta, the mission that landed a lander on one of our near neighbours, and I thought I might share that with you. 2 decades ago, on March the 2nd, 2004, the European Space Agency's Rosetta spacecraft embarked on an audacious journey that would push the boundaries of human knowledge and technology. Launched aboard an Ariane 5 rocket from French Guiana, Rosetta took off on a 7.9 billion kilometre odyssey to rendezvous with and study comet 67P Churyumov-Gerasimenko, a journey that would offer unprecedented insights into the origins of our solar system. Originally targeting comet 46P Wirtanen, Rosetta's course was recalibrated to 67P following a launch delay, illustrating the mission's adaptability and the team's determination. Achieving this feat required a series of complex gravitational assists, slingshotting around Earth and Mars to gain the necessary velocity. Rosetta's eventual speed peaking at 123,000 kilometres per hour, likened to a fly landing on a speeding bullet, underscoring the mission's technical prowess. Upon waking from its 3-year hibernation in 2014, Rosetta commenced its detailed examination of 67P, culminating in the deployment of its lander, Philae. Despite Philae's harrowing bounce landing, it succeeded in transmitting valuable data back to Earth, marking the first ever landing on a comet's surface. This event, although just one of Rosetta's myriad of achievements, captured the world's imagination and highlighted the mission's innovative spirit. Rosetta's journey was fraught with challenges, from navigating the extremes of space temperatures to ensuring the spacecraft's survival in the low sunlight conditions at the edge of our solar system. The mission's ingenuity was perhaps best exemplified by its solar arrays, designed to function efficiently even when sunlight was a mere 4% of that of Earth's orbit. This technology laid the groundwork for future missions, including JUICE's journey to Jupiter. The Rosetta mission not only achieved a historic first in comet landing, but also revolutionised our understanding of comets as dynamic, evolving bodies. From its closest orbits to its controlled descent into 67P's surface, Rosetta provided a continuous stream of data that has enriched our knowledge of the solar system's early days. As the mission concluded with Rosetta's gentle touchdown on 67P, it left behind a legacy of innovation, discovery, and inspiration. The collaboration between the European Space Agency, Airbus, and the countless scientists and engineers across the globe exemplifies humanity's unyielding quest for the knowledge and uncharted territories we continue to explore. And there you have it, another episode of Astronomy Daily for a Monday evening with Steve and Hallie. Thanks for joining us again, and I hope you enjoyed that. We'll be back next Monday with more stories from the Astronomy Daily newsletter. Don't forget to go and get yours from those sites that I mentioned earlier on, and tune in to listen to Space Nuts once in a while with Andrew and Professor Fred as well. And drop us a line on the Space Nuts podcast group on Facebook as well. Say hi. I'll say hi back. And if you've got any photographs, I'd love to see those as well. And we'll see you next week. What do you say, Hallie?
That's all from us. See you.
Short and sweet. See you next time. Bye.
Astronomy Daily, the podcast. With your host, Steve Dunkley.